Hi guys, we are in Unit 4, Day 2 notes. The topic for today is we're going to keep talking about polynomials. Whole chapters about polynomials, but we'll dig a little deeper, talk about the 4 kinds. So I just want to show you the graphs, kind of talk a little bit of background here. So this first graph, number 1, and there's a word box if you want, or you can just write them underneath. But this first graph, number 1, we've seen this before. This is a parabola shape. So this graph would be called a quadratic. Okay, and just going down here, quadratics are degree 2, which let me just throw you an example here. It would look something like y equals x squared, there's your exponent, plus 2x minus 3, something like that. Okay, the one next to it kind of looks like, it has more curve to it, kind of like an S-ish shape. This one is what we call a cubic function. Cubic functions are degree 3. So this one would have an exponent of 3, so something like x to the third plus 2x minus, I don't know, 5, something like that, where the highest exponent is a 3. Okay, and then this next one, let me just separate it here. This next one has a lot of curves, a lot of up and downs, but in general, it kind of has like a W shape. This is what we call a quartic, kind of like quarter, but quartic. Quartics are degree 4. In this example, would be something where the highest exponent is a 4. So x to the 4th minus 3x cubed plus, I don't know, 10. Something like that, where the highest exponent is a 4. And then our last one, which you've done at some point, is just a straight line. This is a diagonal line. This is what we would call a linear function. This is the highest degree of a 1. And here's an example. We've seen stuff like this before, be something like y equals x plus 2. Okay, those are the different shapes. The shapes can flip if the equation is negative, but these are the general shapes. Okay, identifying the following information about each polynomial. So there's going to be these blanks here, and I'll tell you kind of where to find this information. So this first one says f of x equals negative 2 minus 10x minus 3x squared. The first thing is, what is the parent function? Well, the parent function is linear, quadratic, cubic, or quartic, the names that we just learned. And what you need to look at this term, I'm highlighting it yellow, with the largest exponent. Okay, that's where it's going to tell you. So just kind of looking back up here, if it's a degree 2, that means we have a quadratic. And if we have a quadratic, the degree is 2. That little exponent of 2, that tells you the degree. And in general, this one would be a negative quadratic curve. So let me draw you the picture. I typed it in previously. This is what the graph looks like. It says number of real roots. The real roots is where you can actually see the graph crossing the x-axis. So I'm going to highlight it. I can see it in 2 spots. See those 2 blue spots? That means I have 2 real roots. Okay, now here's the catch. The real and the imaginary have to add up to the total. So if I have 2 total and I can see them both, that leaves me with none left, because 2 plus 0, so if I did 2 plus 0, it has to get me back to 2. And then the leading coefficient is I'm still looking at the yellow part, is the number in front of that. So the number in front of that yellow part is negative 3. Let's do another one. So right next to it, we have problem 2, g of x equals negative x minus 2 plus 7x cubed plus 3x squared. Look for the highest exponent. The highest exponent, highlighted yellow, is that exponent of 3. If it has a degree of 3, you can look at our graphs above. This would be a cubic function. Cubic functions are degree 3. Again, I previously had typed this in. This graph looks something like this. Real roots is how many times you can actually see it crossing the x-axis. I highlighted it blue. You can actually see it crossing once. So if I have 3 total and I see one of them, I basically have 2 left over that are imaginary. I cannot see them. Remember, the 1 plus 2 has to get you back to the 3 total. And then the leading coefficient is the number in front. In this case, I'm still looking at the yellow. It's a positive 7. And that's just kind of picking apart the equation. I gave you the graph, but that's kind of those pieces. Okay, same thing, but now the picture is actually more legitimate. So it says identify the degree, type of root, and behavior, so on, for these questions. Okay, number 3, this graph, just look at the shape. In general, from our 4 choices, this shape looks a lot like our cubic function. Cubic functions, all of them are degree 3. Real roots is how many times can you see it, and I'm putting blue little dots there, or marks. How many times can you see it crossing the x-axis? Well, I see it 3 times. So if I have 3 total, and I can see all 3 of them, that means the imaginary is 0. There are none. Okay, I believe this got cut off, so I'm just going to kind of tack it onto the bottom for the end behavior. So as x approaches negative infinity, so as I'm on the left side of my graph, my arrow is going up, so you could even write up over there, but I write positive infinity. And for the other side, as x approaches positive infinity, so I look on the positive side, this side, the other side is going down, so I would write negative infinity. And I just had a hand put that in there, but that could be asked. Number 4 is pretty much just a straight shot, a diagonal line. That means that this is a linear function. Linear functions have 1 degree, 1 total root. And for this picture, I can see it 1 time it crosses the x-axis. That means I have 1 real root. If I have a total of 1 and I can see it, that means the imaginary is 0. Same thing here for end behavior as x approaches negative infinity. So as I look on the left side of my graph, where's my arrow pointing? Hopefully you're thinking it's going down. So that's negative infinity. And vice versa here as x approaches positive infinity. So kind of, let me scroll a little bit up on this right side. This one is going up. So that side is positive infinity. Okay, my last graph kind of looks like if it flipped, it would look like a W. But right now it's upside down, so it kind of has like an M shape. So if it's a W shape or an M shape, it kind of has that form, then this is what we call a quartic function. Quartic functions are degree 4. Let's see how many times it crosses the x-axis. I only see, and I put little highlighted marks there, I only see 2 spots where it crosses, and I can actually see those. So my real roots is 2. So if I have 4 total, and I can see 2, that means there are 2 left over that I cannot see. That would be my imaginary. Let's do the end behavior here. So as x approaches negative infinity, so I'm looking on the left side over here, this one is pointing downward, so that side goes down. And vice versa, as x approaches positive infinity, so on the right side, this one is also going down, so that would be negative infinity. We never write the word up or down, we use the positive infinity or negative infinity. Okay, a little bit more. So that's the part that got cut off. Let's go to problem 6. Just classifying and kind of picking apart the information. So I gave you this polynomial, all these expressions. I want to find the leading coefficient. So I'm going to highlight, look for the piece with the largest exponent. So that's this yellow part. The leading coefficient is the number in the front. That would be a positive 4. The degree is the exponent. That's the little 4. If it is a degree of 4, that means the shape, if I were to draw it, would be if I were to draw it, degree 4 is quartic. Okay, then number 7, again, I give you all these terms here. Look for the spot with the largest exponent. I'm going to highlight it yellow. The leading coefficient is the number in the front, so that's -9. The degree is the exponent, so that's a 3. If it's a degree 3, that's going to tell me the shape of this graph is always going to be cubic. And notice that they're not always in order. Like number 6 is kind of just jumbled up and random, so that's why you have to be careful. It's kind of there to trick you. Make sure you look for the highest exponent. I've been highlighting it yellow so you don't get confused. Okay, a quick little recap. This could show up in some problems, exit slips, and you definitely don't want to forget about this moving forward. Increasing and decreasing intervals. So when I did this, I always made sure we put negative infinity on the left and positive infinity on the right. And then in my class, I talked a lot about roller coasters. So I said you get on the roller coaster over here on the left-hand side and you follow that path. It's kind of a weird roller coaster, but you immediately go downward. So I'm going to put a D for decreasing. Then all of a sudden you have a shift. In this little middle section, you increase, you go up. So I'm going to put an I for increase. And then this last little bit, it changes once again and you go down. That would be your decreasing section. So I'm going to go ahead and kind of just shade this just a little bit. So this orange section is decreasing. That would be decreasing from the left side, negative infinity, all the way to the right side, which would be positive 2. I'm sorry, back up. That would be negative 2. And the reason I'm saying negative 2 is because right here, where that line, that orange spot stops, is negative 2. And then it changes, right? And it starts to increase. This middle section is increasing. It picks up to increase at that negative 2 where we left off, and it goes until positive 2. So it started at negative 2 and it goes until positive 2. And then this whole last section on the right here is decreasing once again. So I'm going to join that, union it with my next decreasing section. That decreasing section picked up at positive 2 and it's going to go all the way until positive infinity.